In this video, we're going to talk about adding and subtracting rational functions. This video assumes that you already know how to multiply and divide rational functions. All right. So the first example you'll actually see has no variables in it. That's intentional. We're going to jog our memories on how to work with fractions efficiently. Okay, so first of all, we have 1/6 plus 1/3. I want you to remember that you cannot simply uh, add the numerators and the denominators. Okay, this is going to give you something that makes absolutely no sense. And the same is going to be true when we deal with rational functions. How do you do this? Well, you might remember we need to look for a common denominator. And preferably the lowest common denominator. In the case of 6 and 3, the lowest common denominator is 6. So we're going to think about multiplying the top and bottom so that you can get a 6 downstairs for both. Now that they're the same, we can add these together. That's 1 plus 2, which is 3 over 6. Lastly, don't forget to simplify. So our final answer is 1/2. Next example, we have 4 over 15 plus 7 over 12. And again, we need to look for the lowest common denominator. So now you might have been taught this way, which is nothing wrong with it. You might have said, okay, well, let's just list all these and say, okay, 12, 24, 36, 48, 60. And you might notice that if you do multiples of 15, you also get a 60. Okay. But it's going to be hard to do this strategy with variables once we get there. So we're not going to do that. We're going to use a different strategy. Let's notice that 15 is 3 times 5, and 12 is 3 times 4. And 4 is like 3 times 2 squared, right? So let's write that as 2 squared times 3. So, so we're looking for the lowest common denominator, right? Whatever this denominator is, it must have at least 2 2's in it because the 12 needs to be the 12 needs to be in there. So we're going to choose 2 squared. We're going to say it needs to have at least 1 3 in there to accommodate for both the 15 and the 12. And it needs to have a 5 in there because there's a 15. Okay. If you do this calculation, you end up with 60, which is the same thing as what we just said. Except it's a little bit more systematic, and this also works when you have variables. So now that we know that, we're going to aim to make these on the top and the bottom both equal to 60. So we're going to get 16 over 60 plus 35 over 60. You add those, you get, is that right, 51? I think that's 51. And of course, don't forget to simplify. So this one is actually 17 over 20. Okay, finally we have 6 over 8 minus 7 over 3. So if you look at the lowest common denominator, that should be 24 because that's 3 times 8 and there's no lower number you can use for that, except make sure you simplify first because otherwise you'll end up with bigger numbers than usual. So for 6/8, I'm actually going to write that as 3/4, and that's a lot easier because it's already slightly reduced. So we're going to say this is 3/4 minus 7/3, and then we're going to make these the same denominator. We're going to get 9 minus 28 over 12. That's going to be a negative fraction. That's going to be negative 19 over 12. Okay, so let's use the same ideas for rational functions. So example 1, we have 3 over x squared plus 1 over 4x minus 5 over 6x cubed. First, let's notice restrictions. The denominators can't be 0. So in each case, that just means that x can't be 0. Let's think about a common denominator. So in principle, you could just multiply them all together, but that's maybe not that smart because you'll end up with a lot of extra stuff that you don't need in there. So let's take a look at each thing. Okay, so each of these 8, 4, and 6, you can convince yourself that it's the lowest common multiple of those should be 24. And then you can look at the variables. You have an x squared, you have an x, and you have an x cubed. In order to accommodate the x cubed, you need to have at least 3 of these x's. So there you go. There's your common denominator. Now that we know what we're aiming for, we're going to make each of these with that denominator. And again, we're going to multiply the top and the bottom by the same thing. So for 8x squared, what are we missing? Well, we need a 3 to make it into 24. We need an extra x to make it into x cubed. So we're going to multiply the top by 3x as well. Next one, we're starting with 4x, and we need to get a 24x cubed. So we're going to multiply by 6x squared. Last one, we're starting with 6x cubed. We need to multiply by 4. And we already have enough x's there, so we don't need to put in any more. Okay, so this is what that's equal to. You'll notice when you calculate that each of these denominators is 24x cubed as planned. So in the numerators we have 9x plus 6x squared minus 20. At this point we can just add the numerators. And now we're done. Okay, so we're going to say it's equivalent to this, except x can't be 0. Let's do a more complex example where it's you have other kinds of factors. So in this one we have 3n over 2n plus 1 plus 4 over n minus 3. So we really have two things going on here. We have 2n plus 1 and n minus 3. And they're not multiples of each other by any means, right? It's not possible to multiply n minus 3 by something, by a number, to get 2n plus 1. So our lowest common denominator is simply going to be the product of those two. Okay. The restrictions, each denominator cannot be equal to 0, so 2n plus 1 can't be 0, and minus 3 can't be 0. That's going to tell us that n can't be equal to negative 1/2, and n can't be equal to 3. Okay, let's make sure we have this common denominator now. So the first one, we're going to multiply the top and bottom by n minus 3. And the second one, we're going to multiply the top and the bottom by 2n plus 1. And now we have a common denominator. Let's write it out. 2n plus 1 and minus 3. Now on the top, we have 3n times n minus 3 plus 4 times 2n plus 1. At this point, it's nice to simplify the top. So let's do that. We're going to expand 3n times n minus 3 to get 3n squared minus 9n. We're going to expand 4 times 2n plus 1 to get 8n plus 4. And then if we collect some like terms, we should get 3n squared minus n plus 4. And we're basically done. Now, why do I say basically? Well, in principle, you should check if the numerator has any common factors with the denominator. In this case, I think this is actually not factorable, so we don't have to worry about it. But if it were factorable, maybe you want to check that you actually don't have any common factors, so you actually are done simplifying. So our final answer is 3n squared minus n plus 4 over 2n plus 1 times n minus 3, and our restrictions are n can't be equal to negative 1/2 or 3. Okay, so let's go on to example number 3. We have something more complex now because we have some quadratics. Okay. The easy way, which is also not the good way, is to just multiply the denominators. But that's going to give us some extra factors that we'll need to cancel out at the end, which is not that convenient. So instead, we're going to make sure to factor first. T squared minus 1 is the difference of squares. That's t plus 1 times t minus 1. And then t squared plus 3t minus 4 is t plus 4 t minus 1. And you'll notice that t minus 1 is shared between those. So we only need it once. We don't need to multiply them together. So our lowest common denominator, you're going to take every factor only as many times as you need it. So t plus 1, t minus 1, t plus 4, and that encompasses everything, so that's all we need. Okay, so we're going to take the first one and multiply on the top and the bottom by the last factor, which is t plus 4. For the second one, we're going to multiply by the last factor, which is t plus 1. Now be careful when you're multiplying the numerator. Remember that fractions always have hidden brackets around the numerator and the denominator. So this is t plus 2 in brackets times t plus 1. Finally, okay, in the denominator we have our three factors. We can just leave it as it is. On the top we should have 2t times t plus 4 minus t plus 2 t plus 1. Now remember your BEDMAS, right? So this subtraction in the middle, do that last. We want to expand each of these first. So we get 2t squared plus 8t minus, you're going to expand this product to get t squared plus 3t plus 2. The denominator stays the same. And then you're going to subtract the top. Remember when you're subtracting the top that you need to distribute the negatives. So it's minus t squared, minus 3, and minus 2. Okay, finally, collect your like terms. You have t squared plus 5t minus 2. You can check that's not factorable, so we don't have to worry about that. And there's our final answer. Now we forgot about restrictions, so let's go back and figure out what those are. So right here, when we factored, that's where we get our restrictions. So we know that t can't be, or let's say t plus 1 can't be 0, t minus 1 can't be 0, and t plus 4 can't be 0, because otherwise you'll be dividing by 0. So that means t can't be negative 1, t can't be 1, t can't be negative 4. So our final restrictions are that t can't be negative 1, 1, or negative 4. At this point, I would like you to pause the video and try the following. Okay, I'll give you the answers in 5, 4, 3, 2, 1. Okay, so the first one, we have xy in the denominator and we have x squared. So the lowest common denominator would be like x squared times y. That's all you need to make it a multiple. So the first fraction we can multiply on the top and the bottom by x to get x squared y on the bottom. And the second one we can multiply by y on the top and bottom. You're going to get a common denominator of x squared y as planned. And then you have 4x times x plus 1 minus 3y cubed. If you like, you can expand this too to get 4x squared plus 4x minus 3y cubed on top. Restrictions, you can see throughout the problem, but especially at the beginning, x can't be 0, y can't be 0. Okay, next one. On your handout, I can't remember if I crossed out this 5 over x. So I'm going to do it as written. Okay, so we need to make sure everything's factored first, right? That's nearly true except for this one. So let's factor that. This denominator x squared plus x minus 2 is going to be x plus 2, x minus 1. And okay, we can say something about restrictions now, which are that x can't be 0, x can't be 1, x can't be negative 2. We can also say something about our lowest common denominator. That's going to be x times x minus 1 times x plus 2. That has all the factors you need. You don't need anything more than that. So the first one we're going to have, we're going to need to multiply by x minus 1, x plus 2. The second one, we're going to need to multiply by x and x plus 2. And the third one, we just need to multiply by x. Okay, so on the bottom, we're going to have common denominator as planned, x times x minus 1 times x plus 2. And on the top, we have a bunch of things that we need to expand and simplify. Here I'm going to take the liberty of multiplying these ones first, just because I think that's personally a little bit easier. So it's 5x squared plus x minus 2. Then this one is 5x squared x plus 2. I'll expand that in a moment. This one's x times x minus 3. So when you expand it, you're going to get 5x squared plus 5x minus 10 plus 5x cubed plus 10x squared plus x squared minus 3x. Denominator is still the same. Collecting like terms. Okay, we have 5x cubed. We have 15x squared. No, that's false. We have 16x squared. We have 2x, and we have minus 10. Now, there's one last thing that we can do, which is I'm actually going to show you how to check your answer if you don't have access to the answer key. Generally, this is okay. Wolfram Alpha is actually built for math, so it will give you the correct results like 99.999% of the time. If you use something like ChatGPT that's not actually built for math, it will make tons of silly mistakes. especially with the algebra, so you won't actually get something helpful. Okay, so if we ask it to simplify this, you can see that we're correct. Right, that's what comes up. There you go. I hope you found this helpful. Happy studying.